Section 9.2 Homework Solutions, Solving Absolute Value Equations. Question number 1. The absolute value of x is equal to 1. This means what value has a distance from 0 on the number line that is 1 unit, or what value is 1 unit from 0 on the number line. So let's draw a number line. The point of origin at 0. Now 1 is 1 unit from 0 on the number line, but minus 1 is also a distance of 1 unit from 0. So the solution to our equation is x equals 1 or x equals minus 1. Question number 2. The absolute value of 2x is equal to 8.2. Now this means what x value such that when it is multiplied by 2 is 8.2 units from 0 on a number line. Well, you know that this x expression could be 8.2 units to the right of 0, or it could be 8.2 units to the left. Solving both equations for x, we get that x is equal to 4.1, or x is equal to minus 4.1. So our solution set is x is equal to 4.1, x is equal to minus 4.1. Question number 5. The absolute value of 4x plus 3 is equal to 23. Now, to get x alone, we must first get the absolute value alone so that we can undo the absolute value operation. So first we isolate the absolute value expression by taking 3 away from both sides. This leaves us with the absolute value of 4x equal to 20. Now to remove the absolute value symbol, recall that 4x is equal to 20, or 4x is equal to minus 20. Solving for x, we get x is equal to 5, and over here we get x is equal to minus 5. So our solution is x is equal to 5, x is equal to minus 5. Question number 7. The absolute value of 6n plus 1 plus 18 is equal to 8. Now again, we need to isolate the absolute value symbol so that we can then reverse that absolute value operation. So first we take away 18 from both sides. And this leaves us with the absolute value of 6n plus 1 is equal to minus 10. But you know that the absolute value can never be a negative number. So this equation has no solution. We write either empty braces meaning empty set, or this symbol meaning no solution. Question number 8. The absolute value of 7x minus 2 is equal to 0. Now here we're trying to find what x value such that when it's multiplied by 7 and we subtract 2 is a distance of 0 from 0 on the number line. In other words, we're trying to find what x value will make this expression equal to 0. Solve for x to find that x value. And we get that x is equal to 2/7. Question number 12. The absolute value of 8x minus 4 equals minus the absolute value of negative 1. Let's simplify this. Now you know that the absolute value of negative 1 is 1, and that minus sign is still there. So again, we have the absolute value of an expression being a negative number, and this cannot be since distance is always positive. So again, this equation has no solution. Question number 13. The absolute value of 7x minus 5 divided by 9 is equal to 10. To undo the absolute value operation, recall that 7x minus 5 over 9 is equal to 10, or 7x minus 5 divided by 9 is equal to minus 10. Let's solve the first equation. 7x minus 5 over 9 is equal to 10. First multiply both sides by 9 to get rid of the 9 in the denominator. We have 7x minus 5 is 90. Now add 5 to both sides. We have 7x is equal to 95. Divide both sides by 7. And we have x is equal to 95 over 7. Now let's solve the second equation, which was 7x minus 5 over 9 is equal to minus 10. Again, we multiply both sides by 9, and this gets rid of the 9 in the denominator and leaves us with the numerator, 7x minus 5, and then 9 times minus 10 is minus 90. If we add 5 to both sides, we get 7x is equal to minus 85. Divide both sides by 7, we get x is equal to minus 85 over 7. And recall our previous solution was x is equal to 95 over 7. So the answer for this equation is x is equal to minus 85 over 7, or x is equal to 95 over 7. Finally, number 15, we have an absolute value on both sides. Absolute value of 3y minus 4 is equal to the absolute value of 31 minus 4y. Now, removing the absolute value from the left side, we get 3y minus 4 is equal to either 31 minus 4y, the positive value. You really don't even necessarily need the parentheses here. This is the positive value of the right expression. Or three y minus 4 is equal to minus 31 minus 4y. So the negative of the right expression. Now, solving the first equation with a positive right-hand expression. First, take the smaller y term away from both sides, or take that back. Let's add four y to both sides to avoid the negative y coefficient, and we get 7y minus 4 is equal to 31. And let's add 4 to both sides. And we get 7y is equal to 35. Divide both sides by 7. We get y is equal to 5. Now solving the equation where the right-hand expression is negative. Minus 1 times plus 31 is minus 31. Minus 1 times minus 4y is plus 4y. Now taking away the smaller y coefficient from both sides to avoid a negative y coefficient if possible, we get minus 4 is equal to minus 31 plus y. Finally, let's add 31 to both sides. And we get y is equal to 27. So our solution is y equals 5, that was from the first equation, and y equals 27.